Hi everyone, welcome back to my channel. It's been a while since I've done some videos here, uh, even though that the whole world is shut down with this coronavirus thing. I've actually been doing some work since I've been laid off of work. So this video's for Conehead, one of my new friends, YouTubers, and he wants to know what I'm doing with my system. This is actually my test rig you're looking at. So I test new things out. I'm able to swap things out and change things and try new ideas and see what works and what doesn't work. So I've been doing this for quite a while now. Now, my biggest problem was for the last while was getting over Unity. Well, now I've officially got over Unity with this motor and I figured it out. And there's one tiny little component that you can add to your system to help make your system over Unity. This one seemed to have made quite a drastic increase in voltage that's being generated by this motor. So I'm just going to go over all the main components here. You can see here I got a 3D printed rotor. It's got 6 N52 neodymium magnets. On the back I got a really nice bearing here, so it's really smooth and really fast. Now I've also been kind of toying around with adding weight to my rotor to make it more like a flywheel. So I had 6 of them, 6 1-inch washers on the back. Seemed to be too heavy and it was drawing way too much power. So I took a couple off. So I got the 4 now, and I'm able to tune the motor with the reed switch to get it to run around anywhere from 250 milliamps to 300. I try to keep it under 300. I've had it as low as 180 milliamps, but this will actually make it try to draw a little bit more power. It makes the motor work a little bit harder at lower speeds. But since I speed it up to a higher RPM, like 800 RPM, that voltage draw actually starts to go down quite a bit. So it starts to become a lot more efficient at a higher speed. So I try to keep my RPM between, I would say, 5 and 600 RPM. So I find I can get enough millivolts out of the system to push through the system, and also help assist with charging the battery a little better and lighting up like lights like I have there. I'll explain that in a minute. The base of my unit's all 3D printed. The spool is actually 3D printed. It's got about 350 turns of 26 gauge wire. It's not bifilar, it's just a single winding on it. Yeah, it's really powerful magnets. So if you don't line it up just right, it kind of moves on you and gets stuck to the coil. But as you can see, it runs pretty smooth. It's a little bit rough running when it's up, spinning it by hand. But as soon as you speed it up, it balances itself out and runs pretty good. Yeah, we were talking about reed switches with Conehead. And yeah, I blew up about 20 of them on my own. So I start to separate the circuits. Let me try to zoom in here if I can. Let's go zoom here a bit. Yeah, that's good enough. So I got four leads there, positive, negative, and then it goes to the reed switch, and it's separate from the power circuit. These 4 here for the power circuit. I also have, I don't know if you can see it, I'll try to zoom in on that. I have also a diode there. So if there is a flashback, it's not going to go back into the front of the system and blow up my reed switch. So that helps out tremendously. Since I've been doing that, I've never had a problem with frying a reed switch. So with this system, it's bare bones. I don't have any electronic enhancements on this to make it put out more power. But this inductor, I'm going to tell you about this inductor that I put in. It's actually quite unique. And it actually goes back to the text of Nikola Tesla. And when he talks about drawing power from the vacuum or from radiant energy, that's why I'm using the PSTD automotive relay switch. It actually creates a spark. So when you got it tuned just right, it's creating enough spark. And it says the only way to extract radiant energy from the atmosphere around us is by a spark gap. So not only is it my timing switch relay, it creates the spark. And right off of that lead there where the spark comes out, it goes to this inductor. It is a small spool that you use for sewing. It's got about 50 winds, a 26 gauge wire on it, and it catches the spark. Now without this inductor on the end there, I don't get over unity. The best this motor will do is about 87%. It was such a dramatic increase. Now this motor is running at 150% over, 150%. So it's 50% over unity right now. So officially this motor is over unity. I'm putting in approximately between 2.8 and 3 watts of power goes into the system. I'm able to light up a 4.5 watt LED bulb with that. So it's bare bones. I've actually got this thing up to about 433% over unity. That's when I add high voltage inverter to it. I can actually power something way more powerful. The other day I had lit up a 25 watt incandescent light bulb, and I was like shocked when I did it, because this little inverter, you can actually purchase it on Amazon. Actually, I got 2 on order right now. I should be getting them in tomorrow. The next video I'll show you that inverter, what it does. But anyways, you can put a small voltage in and get huge amount of AC out of it. So if I'm only putting in only 3 watts of power into the system, and I can light up a 25 watt incandescent light bulb, that right there just shows how efficient, how over unity this device really is. Like an LED bulb doesn't take that much amount of power to run the system versus an incandescent light bulb. It takes a lot more amperage. So I have 2 components that I use, an inverter, and the other one I use is called a boost converter. It can go both ways. It can boost voltage as well as go down and be used like almost like a buck converter. So it has 2 ways of doing it. I'll show you another demonstration in the next video where I could take a 9-volt battery and run an 8.5 watt LED bulb with a little tiny 9-volt battery. It's pretty amazing. And that's actually the most over unity I've been able to achieve with the system. The mechanical version, it definitely has its limitations, but you can still get quite high over unity with these pulse motors. I also have a bridge rectifier with a capacitor there, and I can charge batteries with it. I also have a solar charger over there on the table. I can patch that in, hook it up to the solar charger. The solar charger's got a logic in it, so when you hook up the charging battery to it, it knows what type of battery, lead acid, lithium ion, whatever type of battery you have. It has the logic, so it knows how to pulse power into it. So I'm not doing a direct pulse right into the battery. I'm using the solar charger controller to control the amount of voltage that I'm bringing in from my system into that charger, which I find is probably the smart way to do it. It's safer. You don't have to worry about batteries blowing up. It also has a cutoff, so when it achieves 13.7 volts in the battery, it goes into a discharge mode. So that's actually several reasons why I use the solar charger when I'm working with these batteries, especially lead acid or gel cell or whatever. I find it's just a smart way to do it and a safe way to do it. So I'm going to fire this up. I'm going to show you the spark. It does make a bit of noise, so I'm probably going to have to speak up a little bit louder so you can hear me over the sound of the motor. It's a little bit irritating, but I took the housing off. It seems to take some of the noise away. But the other reason too is I want to see that spark. And ever since I got that spark going and I added the inductor to it, it went over unity right there. So it was a pretty dramatic change from 87% to 150. So I think I did something good there. And I'm going to do some more tests down the road and try to prove my theory correct. I'm going to maybe install this into my other unit that's my other pulse motor that's installed in a camera case, so you can pick it up and take it anywhere you want. So I'm going to fire it up here, and you'll notice this light's going to start right up the second I get it going. Alright, I got it going. It's a little bit loud, so I'm going to have to speak louder. So I'm going to tune it. I'm going to get it down. I got it down to about 2.3 milliwatts, so 250 milliwatts. It goes up and down. It fluctuates a little bit. I can make it go faster, but the light starts to flicker quite a bit. You can see it on the camera. It's flickering. When I slow it down, if I slow it down, the flickering starts to go away. The duty cycle's better. And right now it's hovering at about 360 milliamps going into it. That's what's showing on my meter. One other thing that I forgot to mention, on the bridge rectifier and the capacitor, if I send that into a charge battery, I was getting about 39 volts DC. It's way high, which is okay because there's very little amperage behind it. The second I hook it up to the charge controller, it goes from 39 volts DC, it drops down to about 14, 15, maybe 16 volts. And that's perfect for charging batteries. So, yeah, my coil, 350 turns, 26 gauge wire. I got 4007 diode there. I got a couple of capacitors that are 50, 60 volts, just to smoothen out the power. This little capacitor here is 25 volts DC. That's right beside the rectifier. And it also has a flashback diode, so if there's any issues whatsoever, if there is a flashback or whatever, it's not going to fry anything. So I got two diodes in there. And I also have a connection here. It's got banana plugs. I can hook up my DC source to my my charge controller. So for easy hookup. So yeah, it runs pretty consistent. I've isolated that reed switch, so I don't have to worry about that anymore. What I'm going to do is I'm just going to take the camera off here. I'm going to show you that spark. Just bear with me for a second here. I'll try to take this off without dropping the camera. Okay. There we go. I don't know if you can see that. See the spark? And that spark was nowhere near that intense before I put the inductor in. When I put the inductor in, that spark increased a lot. And because of that, I went over unity. Now I'm at 150% over unity. I did all the math, all the calculations of my amperage going in. Approximately takes between 250 to 300 milliamps to run this, so it's about 3 watts, give or take a couple of points. And I can power up a 4.5 watt LED bulb that takes 350 microwatts of power to run it at 120 volts. So it needs 120 volts to fire up. So I know I'm getting enough spikes in there to actually light this bulb up. So I'll be doing another video on my solid state system. Very easy. You can buy all the components on eBay, and probably, yeah, eBay you can buy it on, and Amazon you can buy it on. So I'll show you those parts, and you can light up huge amounts of power with this, and it's a solid state. It doesn't involve a motor, but it's very interesting, and I want to show that in the next video. Let's put this camera back on here. Sorry about the fingers. This camera's kind of small. Get on there. Okay. Sorry about that. Trying to get it back on the tripod here. So anyways, I'm going to shut it off so you can actually hear me. But you can see the motor. See, it's still spinning down because I put the weight on it. It's like a flywheel. So it's storing a lot of extra energy there, which is also unique to this motor. I've been testing a lot of stuff. Reed switches. I've been trying flywheel designs. I'm trying inductors, capacitors. I'm trying so many different combinations to see what's working, and this seems to be working quite well for me. And I can add stuff to this to make it even put out more power, like an inverter, also a voltage booster, because Tesla always talks about it's not amperage that you're looking for. You got to get high voltage. And when you get high voltage, the amperage comes with it. It'll drop down in voltage and you get that amperage. So the key to this is get the voltage as high as possible. Now, a while ago, I took this motor, and the theory is, depending on your elevation to sea level, will determine how big your spikes come out of that coil. So where I live, I'm approximately 210 meters above sea level. The biggest spikes I got off this thing was about 140 volts AC spikes. I took it to a location we call Rattlesnake Point. It brings me up to about 350 meters, give or take, above sea level. I went from 140 to 220. Actually a little higher, actually pushing 230, 240 spikes I was getting out. So the elevation of where you run this motor, and it proves Tesla is correct. Radiant energy has different gradients per level. So it's about 120 volts per meter. So every meter you go up, the amount of radiant energy level, the potential goes up by 120. So at 300 meters above sea level, I was hitting the mid 200 volt range. I was getting spikes between 220. It all depends too on how many windings you got on the coil, what the size of the windings and the size of the coil. There's a lot of things that determine how big those spikes are going to get. But with this one here that I was using, I was getting anywhere from 220 to 240 volts AC at 320, 310 meters above sea level. Where I live now, it's 210. That's what my GPS tells me. I'm at 210 meters above sea level. So there is some credence to it. Also, John Bedini talked about this, and he had his friend Peter Linderman. They did a test. They had the exact same machines. Peter Linderman went to his cabin up north, and his motor wouldn't work. It wouldn't put out any voltage whatsoever. Went back to John Bedini's place, started it up, it worked. So there's some creative. John Bedini says he went up 3,000 meters, and he was getting 400 to 600 volt spikes with his coil. So yeah, there's some science behind that, and there's so many things. Like I could go on and on and on with ideas and try them out. You just have to experiment. That's what it's all about. Experiment and see what works, what doesn't work. So next video for Conehead, I'm going to show that solid state system that I have, and it should be pretty cool. I think you'll find it quite interesting. Alright, I think I'll call it quits for this video. If you guys like my video, give me a thumbs up. I also have donation at the bottom of the description. You'll see I have a PayPal account. You can send me $1 or $2 and help me develop this and get it out there. I'm making some really good progress with my system, so If you like what I'm doing, hey, shoot me a buck, and it'll definitely go a long way in my research. Anyways, see everybody soon.